All right, this is the Math 6-7 practice test answer key. So you want obviously that in front of you, and you want to be checking your work as we go along here. And if you make mistakes, you want to adjust them or fix them and learn from them, because a lot of times the concepts that are here obviously are the ones on your test, and sometimes the problems here are similar to the ones on your test. So just pay attention and keep in mind what we're trying to do so that you can, just learn from it and do well on your test later this week. All right, so let's go ahead and begin. Number one, you have this table of Alaska, and it's 5 dates on the left in this over here column. Then you also have the high temperature for each date, like 47, the low temperature, and then the change in temperature is what they're looking for. So your task was to fill in the missing numbers. Sometimes it was as simple as subtraction. The high temp minus the low temp tells you the change in temp of 18 degrees on November 1st. Sometimes though you were missing the high temp, but you had the low temp, and then you knew the change in temp was 33 degrees. Well, that would be 33 degrees higher than -5, so that was 28 degrees. In the next row right here, if you had a high temp of 17 and a low temp that we don't know yet, but we know the change in temperature was 29 degrees that day, we went 29 degrees less than 17. So if we do some subtraction, we end up at -12. On January 5th, we know the change in temp was 35. We know the low was -26. So if we go up 35 degrees from -26, we would end up at 9 degrees. And the last one, January 15th, their low was -34. That would be crazy cold. The change in temp that day was 37 degrees. So 37 degrees warmer than -34 takes us to just above the 0 degree mark. That takes us to 3 degrees. All right, so you had to think about what was going on there. Now on the part B, it says look at January 15th and explain how the change in temperature was 37 degrees. Well, you can make a number line here, or you can use some sentences to explain it, or even some math to explain it. But if you knew the high temp was 3 degrees above 0, think of a thermometer. Those are usually good examples of vertical number lines. So if that was the high temp and 0 was not too far from it, 37 degrees lower than that would take us to our low temp for that day of -34. So that's kind of where these three numbers are coming from. The high temp, the low temp, and then over here I just put the change in temperature because they're 37 degrees apart from each other. One is 3 degrees above 0, one is 34 degrees below 0. So you could add their absolute values of 3 and 34 and get that as well. But that is the first problem. Number two, a salesperson flew from Miami to New York. The change in temperature from Miami to New York was -33 degrees. We read that to mean that the temperature dropped 33 degrees. And by the time we got to New York, it was -5, which means when we left Miami, it was 33 degrees warmer than -5. The first thing you had to kind of do was figure out like what the temperature was in Miami when they left, because that's actually part B down here. That was 28 degrees. Part A was a little bit more work though. Some of these calculations show how to figure out the temperature in Miami. Circle the ones that do. Well, we want the ones that would give us an answer of 28 degrees, okay, which this one would equal 28 degrees. You can think of that like the temperature in New York plus the temperature change would result in what the temperature was in Miami, which is 28. This does not work because we would end up at -38. This one would work because remember, when you subtract a negative, it's kind of the same as adding a positive. So this problem right here is very similar to that first one. It's just written differently in that first step. And then this one right here would also end up at 28 degrees. You could think of that as the same thing as the first one, really, because the order of the numbers doesn't really matter when you're adding. And here we have -5 plus 33, and here we have 33 plus -5. So with addition, it doesn't matter if we're adding 2 and 3 or 3 and 2, we still get the same answer, like 5. All right, moving on to the next problem. You had to draw a visual, and I recommended that you do a vertical number line somewhere here on the right. Now, this is what it could look like, but you had to figure out where Sammy goes, where Jeff is, where the fish is, where the sailboat is, and where the bird is. And so from all of those hints over here, it should be something like this. Sammy was at the highest point at 1,237 feet. Jeff was a little bit below him, and exactly how much? Well, that's this number right here, 157 feet below Sammy. So that's how I got to that. I did this minus 157, and I end up at 1,080. The bird was above sea level at 17 feet above sea level. The sailboat is at sea level, that would be 0, and the fish was 36 feet below sea level, or below 0, as they say right there. So that's the order. This was not drawn to scale, but I know I have two very high numbers, and then some, one number just above 0 and one number not too far below 0 also. So that's what it should have looked like. Number 4A, how far apart are Sammy and the fish? Well, Sammy is above, quite a bit above sea level, and the fish is 36 feet below sea level. So that is a difference of 1,273 feet. Yeah, that's the first one. Part B, Jeff and the bird. Well, Jeff is way up here. The bird is above sea level, so you could subtract those, and you end up with 1,063 feet. That's how far apart they were. Sammy and the bird. Well, Sammy is way up here. The bird is 17 feet above sea level, so this is another subtraction one. They are just 1,220 feet away from each other. Number 5, what can you tell me about the sailboat in reference to the others? Well, the sailboat was the only thing that was at 0. And the reason it's at 0 is because it's, it's on the water. I mean, that's basically sea level right there. So that is what we know about the sailboat. The 6th one, what elevation is halfway between the bird and Sammy? There's two ways to do this. The easier way would be just to add up Sammy's height and the bird's height, add those together and get 1,254, I believe. And if you divide that by 2, that'll tell you like the average of them or the middle point of them. And that's one way to do it. Now, the other way would be to kind of come at it like I did right here. This is a slightly different version, but you still end up in the same place if you do it with the same steps. But you figure out how far apart those two things are. And then you cut that in half. And what this tells you is that's the halfway point of the gap between them. So you still have to go back to the bird's height and kind of add 610 to it. Or you could do the same thing with Sammy's height and subtract 610 from that. Either way, you end up with a midpoint of 627 feet. All right. So there's a couple different ways to do that, but you end up with 627 as your answer. The back of that first page, here we go. You had to use this number line, and we know that it wasn't in great shape, but you were good to just understand it and read it and take your time with it. You had to first of all place B on the number line so that A plus B would equal 0. Well, we know that a number plus its opposite will be 0. So if this was 6 units to the right, then B should be 6 units to the left. So that's how we figured out where B was. In part B, place point C on the number line so that A plus C would be negative. Well, if C is anywhere here, it will be a positive answer when added with A. We want the distance from C to 0 to be greater than the distance from A to 0 for this to happen, for it to be negative. So C could be anything from where I have the cursor right now to the left. So that's what you want to say. I'll put a little gap here that C could be any of those numbers on those hash marks or in between them. In part C, the product of A times B, well, A is positive, B is negative, and if we're multiplying, that would mean our signs are different, so our answer will be negative. Because remember, when you're multiplying and your signs are different, you get a negative answer. When you're multiplying and your signs are the same, you get a positive answer. Part D, will the quotient of C divided by B be positive, negative, or 0? Well, kind of like what I just said, same rules apply for division. If your signs are the same, and they are here because C and B are both negative, if we divide two negative numbers, we get a positive solution. All right. And part E, will the difference A minus B be positive, negative, or 0? Well, A minus B, well, it's a positive number minus a negative number. And if you are minusing a negative number, if you're subtracting a negative number, you're really adding that digit with A. For instance, if you look over here, if I said A minus B, but we know B is negative, it's going to be positive. Here's examples. If I was doing 6 minus negative 6, that's really the same as 6 plus 6. So I get 12. So I know that A minus B will really be a positive answer. Now, they didn't ask us really for some of those answers. They just wanted to know, will this be negative? Will this be positive, negative, or 0? So you want to think about those because that's where some of the questions on your test are going. In that bottom problem now there, you had some names here and they told you how far they lived west or east of the zoo. So you had to first kind of figure that the zoo was at 0 and then put the people's locations to the west of it, which would be going negative, or to the east of it, which would be going up the number line and being positive. So represent the relative position of the houses on the number line with 0 being the zoo. So that's what this part was. You should have those. The double wall was a 7, Tarth was at 2, Zoo was at 0, Zeb was at -5, and Amiel was at -8. In part B, how far was each house from all the other houses? Well, I put right here how far Amiel's house was from the other 3. Okay, from Zeb, from Tarth, and from Double W. I did the same thing for Zeb. Okay, you can kind of see how far they are. Same thing for Tarth. Same thing for double wall. Now, if you need more time, just pause the screen and double check your answers there. But part B had a lot of work in it just because you had to figure out how far is this from all the other houses. So there's a whole bunch of answers for part B. Part C we were skipping, and that brings this first particular assignment to a close.